Hello dear students, welcome to Europedia. Today I am here with you to share one of the very important information, that is we collected 70 important questions that were actually asked in BPSC assistant professor interviews. Yes, from the students of Europedia we collected these questions which were asked. I hope this kind of questions are going to be asked in the upcoming interviews of BPSC. Yes, 70 questions, not 10 or 20, 70 questions. It's a huge number, huge number. If you prepare these questions, many of the questions will be covered that can be asked in future interviews. Let's see those questions one by one. Let's see those questions one by one. So branch is from electrical engineering, okay, electrical, and some part of electronics engineering also, like network analysis and I can say control systems. These are common for electrical and electronic and instrumentation also. Let's see these questions one by one. The first question was define electric drives. Yeah, for one of the candidate, these questions were asked in BPSC recently conducted interview, assistant professor interview. What is electrical drive? What is electrical drive? This is from power electronics and electrical machines related topic. Define electrical drives. The second question asked is advantages and disadvantages if we use 10 kilowatt motor for 5 kilowatt load. Yes, this is a logical question. Okay, what happens if you purchase 10 kilowatt motor just for 5 kilowatt load? Okay, what are the disadvantages we are going to have, like technical disadvantages and economic disadvantages? All those they are expected from the candidates. Okay, next question, efficiency of induction motor. Yes, I suggest all of you to remember practical efficiency values of induction motor, transformer and synchronous motor. Not only efficiencies, power factors also. Okay, practical power factor values of induction motor, transformer, typical under load, under full load, typical values I'm saying. See, we know that power factor depends upon load, but under no load, what should be the power factor? If you take induction motor, the no load power factor will be almost from 0.1 to 0.2 lakh. It will be very low. It will be very low. So I suggest you to remember those typical general values of power factor and efficiencies of electrical machines. And not only electrical machine, if you take transmission line and entire power system network, starting from generation to ending to utilization, what will be the efficiency? That is also one of the most repeated questions in interviews. Whatever may be the interview, that type of questions can be asked. Let's see the next question. Power factor of the induction motor at full load. Yes, I told you, right? Power factor of the induction motor at full load. Yes, that is also. And if you go for synchronous motor power factor, we can change it. We can change with help of some devices. Okay, it is going to have lead power factor, lag power factor, like that. So please, and we can over excite it, we can under excite it. We can over excite it and under excite it. What happens if we over excite? What happens if we under excite? So please be careful with the concept of power factors, efficiencies of all machines, electrical machines and power system networks. Okay. Next question was power factor of induction motor at no load. I told you some 0.1 to 0.2 lakh. Efficiency of transformer. There is some difference between efficiency of transformer and induction motor. Induction motor is having mechanical rotation, because of which it is going to have mechanical losses, windage losses, frictional losses. But whereas transformer is a static device, that's why its efficiency is a very good value. See, sometimes you may get efficiency up to 99 also, 99% efficiency. Transformer is going to have only static losses, not dynamic losses. Why? Because transformer is having no, I can say, mechanical rotating equipment. Okay, yeah. Next, reason for difference in efficiency of transformer and induction motor. Just now I explained transformer efficiency is more when compared to induction motor. Why? Because transformer is not having any rotating equipment. Yes, it's a static device, static electrical machine. Next, why armature winding is placed on the stator instead of rotor in case of synchronous machines? Yeah, if you go for a DC machine, armature we kept on rotor, okay, field we kept on stator, but in synchronous machine is exactly opposite. That is, armature we are keeping on stator and field we are keeping on the rotor. There are many reasons for that. One of the reason I can tell you is, see, if I keep armature on the rotor, as it is a three-phase machine, I have to collect the EMF from the machine, from a rotating body, which is very difficult for us. We need 3 brushes, okay, 3 collecting points, and spark will occur. There are a lot of points, okay. Next question, Draw electrical circuit of LED light. Yes, for some candidates this type of questions were asked. You must be, being an electrical engineer or electronic engineer, you must be in a position to draw some small simple practical devices, practical circuits. Suppose I can say for electrical students this may be asked, draw the electrical circuit of tube light. Electrical circuit of tube light. For electronic students like this, draw the circuit of LED light. Draw the circuit of LED light. Okay. What will happen if AC supply is given to a rotor in synchronous machine? Yeah, in synchronous motor for rotors or for field we are giving DC supply. But what happens if AC supply is given? So this type of questions are discussion based questions, means you have to think. You must be in a position to answer it from the basics. I'll tell you. See, this is, I can say this is a crash question. Generally we give DC supply to rotor, then because of the rotation, means we are rotating with help of turbine, then rotor is rotating, that magnetic flux is cutting with the stator winding, stationary winding, EMF is induced in the winding, in the stator winding, we are collecting it, we are using it. But what happens if AC is given to synchronous machine rotor and we rotate? If it is a generator, if it is a motor. So like that, from this question, many cross questions can be asked. First of all, answering this question itself is a very important thing. One must have good basics of, I can say, how EMF induces, what are the basic requirements for dynamically induced EMF, what are the basic requirements of statically induced EMF. So be careful while answering this type of questions. Yes. Yeah. Next question was how to find transfer function in state space analysis. Yes. This was the question asked from control systems to one of our student, that is how to find transfer function. Yeah, see, state space model is what? X dot is equal to x plus bu, y is equal to cx plus du. From that, transfer function is equal to, yes, you can find transfer function is equal to the transfer function is equal to c into si minus a whole inverse into d plus b. I'll write transfer function is equal to c into si minus a whole inverse into b, si minus a whole inverse into b plus d. So this is the formula. See, this is the formula. See, anyone can give this formula. If they may ask you to derive this one also, you must be in a position to derive. See, I never recommend you to remember this one. See, this is D, please, D, not B. I wrote wrong. Let me change it, this one. Yes, sorry. Yeah, I wrote this one wrong. Let me change it. C into Si minus a whole inverse into B plus D, ma. This is D. Okay, yeah. So you must be in a position to derive that one. Sir, how to derive it? Very simple. It is very simple. Okay, apply Laplace, take initial conditions is equal to 0 for state equation and output equation. Substitute this equation in that is in this, make those ups and downs in the equation. Then you are going to get a transfer function, that is y of s by u of s is equal to c into si minus a whole inverse into b plus d. Let's go to the next question. What is observability? Yes. Next question, what is observability? Yeah, states variable analysis is one of the important chapter with respect to interviews. The next question was define controllability. Yes. Define controllability. Observability, controllability. What is observability? What is controllability is very important. Controllability means we must be in a position to change the state of any given system with the help of input. Then that state is said to be controllable. What does it mean by observable? If it is possible to measure the output value at any point of time, then it is called as observable. Otherwise, it is not. Otherwise, it is said to be unobservable. Right? So basic things only. But one must understand the concept, not the definition directly. See, some people will dump the definition. See, interviewing candidates, interviewing panel members are in a position to identify you if you are mugging something. Okay, your delivery itself says to them, conveys to them that whether you mugged or you understood. Okay, let's go to the next question. What is the best method to find stability and why? There are many methods to find stability. By using RH criteria, by using root locus, by using state space, by using Nyquist plot, by using Bode plot, by using polar plot. Which method is the best method and why it is so? Yes. What is a slack bus? This is from power systems. Yes, slack bus. See, in power systems there is a classification of buses. Why? See, slack bus is a peculiar bus. It's not like other buses. Practically speaking, it does not exist practically. We are taking it, that is called as a reference bus. Slack bus is called as reference bus. Okay. See, I am not giving the complete explanation of all the questions. Just in this video I am discussing what are all the questions asked. At some places I am giving the answers slightly. Yes. Let's go to the next question now. Explain about high voltage engineering lab. Yeah, one of my student, Europedia student, yes, my student, Europedia student was an MTech graduate in high voltage engineering, HVE. She completed her M.Tech in HVE from power systems. Okay, so she worked as a professor in a college. So they asked in lab what kind of experiments you conducted, what are the equipments your lab is having, all that. Okay, they may check that type of questions also from you. Next question, what happens if zeros are added to a transfer function? Yes, see, we can add zeros, we can add poles to the transfer function. There are many changes and many advantages if you add a zero properly to a transfer function. Yes, there are some list of points, effects of adding a zero, effects of adding poles. Next, what is contingency? Yes, in power systems this will happen. What is contingency, they asked. Yes, the next question was reason for calculating contingency. Why you are calculating contingency? So yeah, these questions for power system students. If you select power systems as your favorite subject. Next question, advantages of Bode plot. Yes, see, we have Bode plots, polar plot, Nyquist plot, state space, basic method, that is RH criteria for finding stability. But why we are going for Bode plots? What is the advantage of Bode plots when compared to others? That was the question. Yes. Next question was define bus in power system network. What is a bus? What is a bus? Okay, bus is simply a node. Bus is simply a node in power system network. Then immediately they will ask you what is the classification of buses, what is the need of classification of buses, like that. See, if you answer, they keep on asking the questions until they satisfy. Okay, next, what are the performance indices of a transmission line? Yes, if you take a transmission line, how you are going to measure the performance of a transmission line? Very simple, by using efficiency and voltage regulation. Every electrical machine, electrical equipment is going to have some performance indices. Performance indices are the one which will decide the performance, means whether that electrical machine or transmission line is having a good performance or not. That is efficiency and voltage regulation. Yes. Next question, why high voltage are used for AC transmission? Yeah, we are going for higher and higher voltage of transmission for AC transmission. What is the need of that? Why can't we go with low voltage transmission? There are several reasons. One is power loss, another one is power system stability. Okay. Yes, next question, how many types of over voltage are there in power system network? Yes, in power system network over voltage will occur. Yes, how many types of over voltage are there? Very simple, lightning over voltage and switching over voltages. Yes, but one must have good knowledge on those two. It's not just listing the over voltages. Immediately they'll ask you what is lightning over voltage, what is switching over voltages. In these two, which one is going to be high for what operating voltage? Okay, how switching voltage over voltage will come, how to protect a system from switching over voltages, how to protect the system from lightning over voltage, like that. Many questions will come. Okay, yes, we will be in a position to answer those questions if you have the concepts. That is very important. Yes, next question, what is a balanced system? Yes, a power system network, if it is unbalanced, there are many disadvantages. Okay, what does it mean by a balanced system first is the question. Yes, next question, difference between circuit and network. Yeah, this is a question from network analysis. They will start from very basic questions. What is the difference between circuit and network? Next, what is the difference between loop and mesh? Loop and mesh. Square wave voltage with period t, it is wave. It is wave. Yes, square wave voltage with period t and half period t by 2 is given to an ideal capacitor and asked to sketch current waveform. Very good question. Yes, they will give you a square wave to an RC network or to even to a capacitor, ideal capacitor, and they ask you to sketch a current waveform. What is the current formula? I is equal to C dV by dt. Use that and draw the first this voltage waveform, square waveform. Total period is t, half period is t by 2. Then do that and you are going to get that current waveform. It's very good question. If you answer this type of questions in correct way with the correct approach, then definitely your chances of selecting will be increases. Next question, define time constant. Yes, define time constant. What is time constant? There is a definition for time constant, like it is a time taken by the step response to reach 63.2% of its final value. And again they may ask you like there are different types of time constant, like electrical time constants, mechanical time constant, and thermal time constants. What is the difference among these three? Which one is high value? And what is the time constant of series RC network, parallel RC networks, series RL network, parallel RL network? Like that, many questions they will ask. They'll start at this question. Okay, extension will be very big. Okay, next, which grounding method is used for synchronous generator? There are three types of groundings for synchronous generators. One is solid grounding, resistance grounding, reactance grounding. Peterson coil grounding. Okay, this type of groundings are there. Which grounding method is used for synchronous generator? Synchronous generator. Yes. Next question was types of transmission lines. Yeah, types not IFMA. This is off. Types of transmission lines. Generally, classification of transmission lines. One student got confused. He said to me, sir, I got confused in the starting. What is the types of transmission lines? I know classification of transmission line. Both are same. Types and classification both are same. Short, medium, long, based on physical distance and voltage. Okay, physical distance and voltage we are applying. Depending on wavelength, we have only two classifications, that is short and long. No medium transmission line. Next, representation of transmission lines. Yes, short, medium, long. In short transmission line, we are neglecting the shunt capacitance. In medium transmission line, we are taking it as lumped. Short and medium are lumped. Long transmission line, we are taking it as a distributed parameter model. Yes. What is the power factor and what is its significance? Yes, this is one of the very good question. Power factor. See, always we need a good power factor. Highest value of power factor value is 1, unity power factor. What is power factor? What is the significance? Why we need a good power factor? What is the advantage if we have good power factor? What are the disadvantages if the power factor is less? Next question, how to improve power factor? Yes, there are several methods to improve power factor, suppose if the load is lagging, then we are going for capacitive compensation. If the load is leading, we have to go for inductive compensation. Like that, there are many methods to improve power factor. Yes, what power supply is used in traction? Yes, in railways, see, railways uses some different kind of power supply. What kind of power supply is used in traction related to railways? Okay, next question, induction motor VYF control. Yes, if you want to speed control the induction motor, there are several methods. In that, explain about V/F method, voltage to frequency ratio method. Yes, next, significance of RMS value. See, in AC analysis, in AC power systems or machines or networks, whatever it is, we are using RMS value frequently. For the calculation of average power, we are using RMS voltage and RMS currents. P average is equal to V square by R, where that V is VRMS square by R. VRMS is equal to VM by root 2. What is the significance of RMS value? You have to explain with an example. Okay, that is also a good question. State and explain maximum power transfer theorem. For many students, this question got asked. Okay, state and explain maximum power transfer theorem. Okay, both in AC and DC. Next question, what is not coding, this is loading effect. What is loading effect? This is also one of the very important interview questions. This type of questions can be asked in interviews like BARC, DRDO and ISRO also. Okay, that is a good question. Yes, next question asked was is, what is the difference between mesh and loop? What is the difference between mesh and loop? I think this was already asked. Yeah, next question, what is linearity? Yes, most frequent question for both E and EC, linearity. If a system or element satisfies both the superposition and homogeneity, then that system or circuit is said to be linear. Okay, yes, next question, what is duality and what is the purpose of duality? Not ability, this is duality. Yes, what is the purpose of duality? Yes, there is a concept in network analysis called duality. What it is and what is the purpose of that? Yes, that is also a good question. What is the maximum phase angle that will be provided or supplied by a single series RC network? Maximum phase angle that is provided by a single series RC network is less than 90. Exactly 90 is not possible. You can get 89.9999 degrees also with one RC network, but not 90 degrees. Yes, that is also a good question for both E and EC. What is the balanced system? That was already asked. Explain about self-inductance and mutual inductance. Yes, for electrical students, this is very important. Suppose if you take your favorite subject as a transformers or power or electrical machines, definitely this question will be asked, self-inductance and mutual inductance. Yes, next question, what is resonance? Yeah, see, many students will answer resonance only in electrical point of view. That is, they will take a series RLC network, they will say that XL is equal to X in magnitude and VL plus VC is equal to 0, current will be maximum. Not all that. What is basically resonance? If the input frequency is equal to system natural frequency, then that condition is called as resonance. Okay, so but see, after that you can extend to electrical devices or electrical circuits. Next question, what is a filter? Yes, for electronic students it is very important question. What is a filter? Yeah, Draw voltage regulation curve and explain. Yes, if you take a transmission line or a transformer, voltage regulation curve will be there. Then they will ask you to draw it and they will ask you to explain, and they will ask you many cross questions when you are explaining what is the power factor here, what is when you get negative voltage regulation, what does it mean by negative voltage regulation, like that many questions will be asked. Next, draw the circuit of a band pass filter and explain. They may ask you to sketch band pass filter in two ways. One is with only passive elements, another one is the passive and active elements. Okay, draw band pass filter and explain it. Okay, next, what is the formula for apparent power? What is the formula for apparent power? My S is equal to VI conjugate. They will ask you what is the purpose of conjugate, why you are taking conjugate for I only, not why not for V. Okay, yes. Next question, what is conjugate in S is equal to VI conjugate? Yes, I conjugate. Yeah, next, why conjugate is for I, why not for V? Yes, from passive power sign convention we have to explain. By using passive power sign convention we have to explain. Yes, next, what is the condition for maximum receiving in real power for a transmission line? Yes, when we are going to get maximum receiving in real power in transmission line. Next question is, what is Ferranti effect? One of the famous effect, that is Ferranti effect. Next, what is skin effect? What is corona? These are very basic questions, very basic, and I can say famous topics in electrical engineering, power systems especially. Next, what is the condition for zero voltage regulation for a transformer? Yes, for a transformer, if you want to have zero voltage regulation, what is the condition? Next, what is the frequency? What is the frequency of zero sequence components? If something is missing, that is frequency of zero sequence component. Zero sequence component. Yes, sir. If the frequency of voltage is 50 Hz. See, unbalanced system we are going to divide into three parts. One is by using symmetrical components, that is positive sequence, negative sequence, and zero sequence. Now the question is here, what is the frequency of zero sequence components if the actual component's frequency is 50 Hz? Same 50 Hz only. Some people will misunderstand that zero sequence components are DC components. No, zero sequence components means the phase sequence of ABC is there is no phase sequence. Okay, all three phases will come at a time. Positive sequence means phase sequence is same as that of original vectors or phasors. Negative sequence means the phase sequence is exactly opposite to original phasors. But zero sequence means there is no phase sequence. All three will become maximum at the same time. All three will become zero at the same time. No phase angle difference between zero sequence components. That is what does it mean by zero sequence components? Those are alternating quantities only with the same frequency as that of 50 Hz. That is original quantities frequency. Fine. Next question. What is the purpose of Laplace transforms? Yes. See, entire control systems we are going to deal with the Laplace. We are going to deal with Laplace domain. Why we are going for Laplace domain? That is one of the famous question. Next, what is a stable system? How we are going to define the stability of a system? See, stable system means not only from a control system point of view, from power system point of view also they may ask you what is a stable system. Yes. What is controllability? That was already asked. What is observability? Asked. What is a dynamic system? Yes, we have two types of systems, dynamic and static. If a system is going to have energy storage elements, at least one, it is called as dynamic system. Yes. What is the difference between natural response and transient response? Yes, this is one of the famous question. Many people will say that both natural response and transient response both are same, both are not same. There is a lot of difference. Yes. What are the advantages of negative feedback? Yeah, we have two types of feedbacks, negative feedback and positive feedback. What is the advantage? What are the advantages of negative feedback? There are several advantages of negative feedback. Next question is define time constant. That is already done. Yes. What is bandwidth? Yes. What is bandwidth? Yeah, there is a definition for bandwidth for first order system, for second order system. General bandwidth definition is there, but there is some particular relationship between time constant and bandwidth of a first order system. So like that, what we can get. Yeah. Next question is, what is the relationship between time constant and bandwidth of a first order system? Yes, I told you, right? Yeah. Next question is, which controller is used to improve stability? Yes. See, there are some controllers and compensators are used to improve stability and to reduce steady state error. We know that PD controller, proportional plus derivative controller, is used to improve stability, and a PI controller, proportional plus integral controller, is used to reduce steady state error. Next, in frequency response methods, which one is the best method to find stability and why? I told you there are several methods like Bode plot, polar plot, Nyquist plot. Yes. In those methods, which one is the best method to find stability and why it is the best method? Yes. Next question is, what are the limitations of RH criteria? Yes, RH criteria is having some disadvantages or limitations. what are those limitations. See, actually looking like 70 questions but from these 70 questions 70 more questions can be framed. For each question there will be an extension. Please all of you prepare all these questions with its extensions with good solutions, then definitely you can crack any interview for electrical engineering. The subjects are like I took the subjects like network analysis, control systems, power systems and electrical machines. Some part we covered power electronics also. The very first question was electrical drives. Power electronics subject also got partly covered. Thank you.